All right, guys, today we got drawing scatter plots and finding best fitting lines. That kind of goes hand in hand with what we did yesterday as far as finding equations of lines, except today, not going to be perfect lines, scattered points. All right, three quick words here: positive correlation, negative correlation, and no correlation. Positive correlation is if y, the y value, y coordinate tends to increase as the x increases. A negative correlation is just the opposite. The y tends to decrease or go down as x increases. And no correlation, there's just no pattern. I mean, you can have dots or points everywhere in your graph, and sometimes x and y increase, sometimes they decrease, sometimes x increases. Just they're everywhere. Here's a picture of all three. Positive correlation looks like this. You can obviously tell this first picture here, as x is going this direction, that's increasing, y is going that direction, so they're both increasing as you go left to right. The negative correlation is the second one. As x is increasing this way, the y, obviously the points are going down, so as negative correlation. And this is what the no correlation looks like. Just no pattern whatsoever. So positive correlation is like a positive slope. Negative correlation looks like a negative slope. No correlation looks like there's not even a slope, because there's not even a line that you could draw. And what we're going to try to do today is draw the best line we can. Like maybe it goes right through there, or maybe it goes, right through there. The best line possible. All right, the directions here say describe the correlation shown by each scatter plot. The first one is definitely positive. It's going up. Let's see what that is, by the way. It is positive correlation. It says the subscribers to cell phones versus service regions. So yeah, as subscribers go up, also the regions who have cell service goes up. That's pretty obvious. And this one's obviously negative. It's going down. And let's look at what it says. Subscribers to cell phone services is going up. Well, that's happening. Well, corded phones, you may not even know what those are. Those are the kinds that you have to plug in. Sales are obviously going down. I mean, that's obviously going to happen. The more cell phones there are, or subscribers, the fewer old-timey phones there are. Okay, one big thing today is called the correlation coefficient, and we're going to call it R. We're going to use R. R stands for correlation coefficient. I guess it calls it correlation. What it does, the R tells you how well a line fits. How good of a line is it? How close is the data to a line? And R is always between -1 and +1. Always between there. A lot of times they'll say this. They'll say absolute value of R is less than 1. 1 would be a perfectly, perfect line. With a +1 slope, -1 would be a perfect line going down. So if it's real close to being a negative correlation, like a strong negative correlation, R is going to be really close to -1. If it's going to be real positive correlation, R is going to be really close to 1. If there's no correlation at all, R is going to be close to 0. So anywhere in between, it's kind of medium or whatever, but the closer to 1, the better fit a line is. The closer to -1, a better fit a line is. It just goes the other direction. The closer to 0, the chance is a line doesn't even fit the data. Okay, so I'm going to make you practice that just a little bit. It says for each scatter plot, tell whether the data have a positive or negative or no correlation, and then tell whether the correlation coefficient is closest to -1, -0.5, 0, +0.5, or 1. And that's just a guess for right now. I'm going to show you tomorrow on our calculators how to find the correlation coefficient, so be ready for that. The first one is obviously it's positive. Points are definitely, as x is increasing, that's definitely got a positive. So it looks like you could draw a line. I don't know, maybe something like that would be the best line. But because those points aren't really, really close to a line, I'm probably going to say it's closest to 0.5. Closer to 0.5 than 1. That'd be my guess. The second one is definitely negative, so I'm going to put negative. Also, those points are really, they're really close to a really good line right there. So let's say that's really close to -1. And the last one, obviously, those points are they're just all over the place. So we would say no correlation for this one. I'm going to run out of room, let's put no core. And then, obviously, with no correlation, my R would be really close to 0. So one more time, if R is close to 1, that means the line fits it really, really well going positive. -1 fits it really, really well going negative. The closer you get to 0, the worse. The line doesn't even fit it. And the last slide says, let's see, the table shows the number in thousands of alternative fueled vehicles in the United States, X years after 1997. So basically that means, most pretty much electric cars, I guess, are hybrids, where what's happened since 1997, you can see in thousands, those cars have really gone up. And so I went ahead and graphed this for you. I'll put the X is the years since 1997. So that one right there represents 98, 99, 2000. And then going up, I put the number of thousands of cars that are in use. And obviously there's a positive one. And this is approximate the best fitting line. And I'm going to be honest with you. What they kind of want you to do is to draw a line like this. And I messed that one pretty bad. And find 2 points that you think are really, really close to it and do point slope for them. Like you may pick these two and do what we did yesterday with point slope and get a good line. However, your calculator will give you the best fit line. So what I'm probably gonna do tomorrow, instead of making you, I'm gonna find out for sure, but I think what I'm gonna do probably is let you use a calculator and find the absolute best fit line for the data, because you need to know how to do that too. So that's really all there is today. A lot of scatter plots and some R values, correlation coefficients. So make sure you got the terms down. And I will see you tomorrow when you come in and we'll work on it like we always do. Look forward to seeing you. Bye.